Hey guys, it's Off by One here, and today we're going to be solving missing number. In this problem, we're given an array called nums, and they're telling us that it contains n distinct numbers in the range of 0 to n. And in the end, they want us to return the only number in the range that is missing from the array. So for example, here, we have an array with 3 distinct numbers, meaning that our range is going to be from 0 to 3, because that is our n. And as you can see here, the number 2 is missing from this array here, and that's why we return 2. There's many ways to solve this problem, but I'm going to show you two. The first one is going to be a more intuitive and easier solution to understand, and the second solution is going to be using logical operators, which is what they expect you to use for this kind of problem. So here I've written the example from the problem, where nums is equal to 3, 0, and 1. So that means our range is going to be from 0 all the way to 3, like we discussed. So that means this array would look like 0, 1, 2, and 3. And as you can see, 2 is missing from this array here. But how do we find that out just using our intuition? Well, what we could do is just add every number in nums and then store that in a variable, and then add every number in the range and store that in a variable. And then at the end, we can just subtract to see the difference. And whatever the difference is, then that's our missing number. So let me show you what I mean. So let's just make a variable. Let's call it nums add. And here we're going to store the addition of these three numbers. So 3 plus 0 plus 1. That is 4. And now we're going to have our other variable, range add. And here we're going to store the addition of all of these numbers, so 0 plus 1 plus 2 plus 3. And that would be 6. And at the end, we can just do range add minus nums add, and then we can just return that, because that would give us a 2. So we would do return range add minus nums add. And this is 6 minus 4, and that would give us a 2, which is correct. And if you implement this the most efficient way, your time is going to be O of n, and your space is going to be constant. So the reason it's O of n is because you're only iterating through this array once, and the reason the space is constant is because this array here doesn't actually exist. You can just use a for loop, and you can say for I in range all the way to the nums array. And then this should give you the proper answer, maybe with some slight modifications, but I'm sure you get the point. So this was actually supposed to be the length of nums, but same thing applies. So now we're going to go over the actual optimal solution that they want you to use for this kind of problem. So before we get started, I have to tell you what the XOR operator is, because we're going to be using that. So all XOR does is return true only if the bits are different, and that's why it's called XOR. It stands for exclusive OR. So how are we going to use this? Well, one thing we can gather from XOR is that, like I said, it'll only return true if the bits are different. And if the bits are different, then that means that's probably going to be a missing number. So what I mean by that is, let's compare 0 to 0. I know it's not how we would compare it normally, but I just want to show you what I mean. So if I do 0, 0, 0, XORed with 0, 0, 0, all of this is going to be 0. Now let's try 3, for example. 3 would be represented as 1, 1, and XORed by itself would be 1, 1. And as you can see, this would also return 0. Okay, well, what would happen if we did 3 XOR 0 XOR 1? So that's this whole array XORed by itself. And on top of that, we added this range here. So we would add XOR 0, XOR 1, 2, and 3. What would this evaluate to? Well, like I said here, if the numbers are the same, then they're going to cancel out and just be 0. And this also works for this long equation here. So for example, 3 and 3 will cancel out, so we wouldn't have to XOR 3 with self, because that would just be 0. And same thing with this 0 here. This would cancel out, and also this 0 will cancel out. And same thing with 1 here. This would cancel out, and this would cancel out. So now we're just left with 2 by itself, and that is the missing number, so we would just return that. So how do we implement this in the code? Well, to start, we want to set up a variable. I'm going to call it m, and that's going to stand for missing number, and I'm going to set it to n here, which is 3 currently, because that's how many distinct numbers we have in this array. And then from here, we want to iterate through this nums array. So iterate nums. And then in here, we want to do m is equal to m XORed with I, which is our iteration counter, and then XOR that with our current number. So that's nums at I. And then at the end, you just return m. So I know that looks too easy, so let me show you that it works. So let's say m is 3 to begin with. We're going to XOR that with I, which would be 0, and then nums at I would be 3. So we XOR that together. So that's our first iteration. Then after that, we take this result, XOR it with the next iteration, so that would be 1 XORed with 0. Okay, so next iteration now, I'm going to write it down here. That would be 2 XORed with 1, because that is the current number we're looking at. And as you can see, if we cancel out the like terms, then we would get these 3's cancel out, this 0 cancels out, and these ones cancel out. And we're just left with 2. So that's how the algorithm works. So our time complexity for this would still be O of n, so not much of an improvement, but it is how they want to solve the problem. And our space is going to be constant because we're only using this variable here. So now let's get into the code. So to start, we're going to set up our variable to keep track of our missing number, and that's going to be called missing number, and I'm going to set that equal to the length of nums. The reason I'm setting it to the length of nums is because this is how many distinct numbers we expect to have in our nums array. From here, we just want to iterate for I and num in enumerate nums. So all this is doing is giving me an index and then also giving me the current num at the index. So what I'm going to do is set missing number equal to missing number XORed with the current iteration and XOR that as well with our current number. And then at the end, we can just return missing number, and that should work. But this part here can be shortened to this, just to make it look a little nicer. And now submit the code. Made a typo here, it's supposed to be number, but now it should work. So as you can see, this is probably the most efficient solution you can get, and now I'll go through the code manually. To start, we're going to initialize our variable called missing number equal to the length of nums. So here's our nums array, and we're going to do the same thing we did in the example, just to keep it consistent. And the length of this nums array is 3, so our missing number is going to be 3, which is already initialized there. So that's checked off. And now we want to iterate. For every num in nums, we just want to do this calculation here. So currently missing number is 3, so I'm going to write that down for I is equal to 0, because that's our first iteration. Our missing number is going to look like this. So I'll just call it M. It's going to be 3 XORed with our current iteration, which is 0, XORed with num, and the num is currently 3. From here you can see that 3 and 3 cancel out, so our M is just going to result in 0. So I'm going to update that here. Now we go to our next iteration, which is I equals 1. So I is equal to 1. We're going to do M is equal to the current value, which is 0, XORed with I, which is 1, and then XORed with our current number, which is 0. So as you can see, these zeros don't produce any value, and we're just left with 1. So our M is now equal to 1. So I'm going to update that. And now we go to our last iteration for I equals 2. So for I equals 2, M is going to be equal to the current M, which is 1. So we're going to do that. XORed with I, which is 2. Then XOR that with our current num, and here you see it's 1, because that's C indexed at 2. And as you can see, this one here and this one here cancel out, so we're just left with 2. And then that's it for our for loop, so we can just check that off. And now we just return whatever the value of missing number is. And as you can see, the value is 2, and I'll just update it here to make it a little clearer. But yeah, the answer is correct, and we know because that's the problem we solved earlier. If this video helped you in any way, please leave a like and subscribe. Thanks for watching, and I'll see you in the next video.